What can we learn from misclassified data points? Imagine you're trying to teach a computer to tell apples from oranges. Sometimes it gets it right, but other times it makes mistakes. Those mistakes are called misclassified data points. They happen when the model predicts the wrong label, like calling an orange an apple. These errors are common in supervised learning, where the model learns from labeled examples. But instead of just seeing errors as problems, we can learn a lot from them. First, looking at misclassified points helps us see where the model struggles. For example, if the model keeps confusing two types of fruit, maybe those fruits look very similar. This tells us that the model might need more training data for those cases or better features to tell them apart. If the model makes more mistakes with certain classes, it shows us which classes are harder to distinguish. This helps us decide where to focus our efforts to improve accuracy. Second, misclassified data can reveal issues with the training data itself. Sometimes, labels are wrong or data points are noisy or outliers. These can confuse the model and cause misclassification. When we find these errors, we can correct the labels or remove outliers. Fixing these issues makes the model more reliable and better at predicting new data. It also shows us if we need more diverse examples so the model can learn better patterns. Third, studying misclassified points helps us build more trustworthy AI systems. When we understand why errors happen, we can explain the model's limitations to users. This is especially important in sensitive areas like healthcare or finance, where mistakes can have serious consequences. Knowing where the model might fail allows us to be transparent and responsible in deploying AI. Tools like confusion matrices help us see which classes are often confused. Error analysis shows us specific mistakes, and threshold tuning helps us decide the best point to classify data. More advanced methods, like error likelihood matrices, can tell us which errors are most common and help us interpret the model's behavior better. This is useful in real-world applications like self-driving cars or medical diagnosis, where understanding errors can save lives. When we think about AI tools like ChatGPT, DALL-E, Midjourney, and productivity plugins, learning from misclassified data points is like fine-tuning their outputs. For example, ChatGPT improves responses by learning from user feedback on incorrect answers. Image generation models like DALL-E and Midjourney get better at creating images when they understand where their outputs don't match expectations. Productivity tools that classify or predict can also use error analysis to become more accurate and trustworthy. In the end, misclassified data points are not just mistakes. They are signals that guide us to improve models, fix data issues, and develop more responsible AI systems. They help us turn errors into opportunities for making smarter, more reliable technology that we can trust in everyday life.